Hey everyone, welcome back. The MNIST database is the Hello World example for students who want to learn machine learning. The dataset includes 70,000 28 by 28 pixel grayscale images of handwritten digits. This exercise aims to train a machine learning algorithm to recognize the numbers we have in an image, even though they're never the same because people have different handwriting. If you write the number 3, and I write the number 3, we'll have similar but slightly different versions, right? So how does the computer distinguish between images of 3, 6, or 9? It boils down to the fundamentals of computer science and electrical engineering. All information can be broken down into zeros and ones. Here's how this happens. The handwritten number 3 can be represented in the following way. Each pixel in these images has a value between 0 and 255 that describes its shade of gray, where 0 is white and 255 is black. In computers, all information, including these pixel values, is stored in binary form, using combinations of zeros and ones. When we consider the pixel values in MNIST, or any digital image, these numbers are converted into a binary format, so computers can store and process them. So we see different pictures of the number 3, but they are pictures with similar number sequences for the computer. To solve the MNIST task via machine learning, the computer is trained to identify and differentiate these numerical sequences, enabling it to recognize digits from 0 to 9. This example is fundamental because it shows how we can turn different types of information from the world around us into data that computers can read. Similarly, videos are thousands of pictures composed of hundreds or even thousands of pixels. Each pixel, in turn, corresponds to a number represented in binary form, with only zeros and ones. Even sound and written speech can be represented as sequences of zeros and ones. This is how computers receive the necessary structure to learn. They use this information to find patterns, study similarities, and ultimately learn how to execute different types of tasks. We don't always appreciate how remarkable human brains are. We can see the world around us and collect a lot of information simultaneously. Our minds process countless details subconsciously, using our senses to absorb what we see, hear, and taste. This complex system allows us to understand and respond to the world, helping us to interact meaningfully with everything around us. AI researchers aspire to provide machines with such capabilities, utilizing tools that collect data through sensors, video, audio, texts, social media, satellite images, and internet browsing patterns. They gather information by scraping the web, accessing APIs, and harnessing big data analytics. This wealth of data enables them to train algorithms, refine machine learning models, and enhance artificial intelligence systems to better understand and interact with the world. Data scientists often say, especially when building AI models, garbage in, garbage out. High-quality data input ensures excellent model output.